I had mentioned in our last video I was going to show you something about example 3. I'm not going to do that because that's a contrived problem that is very similar to something like what you do from example 2. So we won't look at that one. You can look at their steps on page 460 if you want to see another way or a different kind of rational addition of rational expressions. So let's look here. In example 4 and example 5, they give you two different techniques. I'm going to show you one of the techniques, and then if you want to use the other one, you can look at it. This is actually the technique that comes from example 4. This is the way I like to deal with complex fractions. And so you have a complex fractions when you have fractions over fractions. This is what they present you with on page 461. The way you should look at this is you have a fraction with a whole number on top, and then you have two fractions at the bottom. And you want to piece them out that way. You want to simplify the top first and then deal with the bottom second. And what I mean by that is let's simplify this x over y plus 1. So we're going to write that as x over y. Common denominator would be y. So we're going to have y over y. That's how 1 gets turned in, y over y. That's 1. That allows us then to have the combination put together with that common denominator of y. So we have x plus y over y. That's the top piece. All right. So let me move this. The second piece then is the bottom part. And that's going to have this common denominator of xy. So I need to multiply top and bottom here by y, top and bottom here by x. And that gives me that on the bottom now. So I'm going to put in the big long. That's the same thing all the way across there. That's the fraction bar that divides the top and the bottom from the very beginning. So I'm going to keep that all on the way. And then on the bottom here, I'm going to have this xy as my common denominator. And then I have y squared. Y times y there is y squared minus 1 times x gives you x. And so what I have is still a complex fraction. What do we do with this? You're going to invert the bottom because all this bar here means is this, divide. So if I show, I'm going to clear a little space here. If I show the top, I'm going to go x plus y all over y. I'm going to divide that. I'm going to show old school division here so that you recognize something from your past maybe. The denominator is dividing the numerator. We're talking about the complex fraction part of it. Now I have two fractions that I'm dividing. So the rule says this, you got to invert and multiply. You have to invert and multiply that second one. Now, if you want to skip this step right here and just go right to this step, you may do so. So this becomes really x plus y all over y times. So if you want to go from this step right up here to this step right here, you're free to do so. I'm just wanted to show this right here, this step, to recall some of your past work. And I'm invert and multiply. So I multiply by the reciprocal of that second fraction. So it looks like this. All right. So now, this is where I talked about earlier. You can do some canceling before you actually multiply these together. You can multiply straight across, but let's simplify if we can. So when you have multiplication, denominators can simplify with numerators, or denominators in one of the fraction can simplify or cancel with the numerator in the other one. That's what we got going on here. We have a y in this first one, and it can cancel with the y that's in so the y in the denominator of the first one can cancel with the y in the numerator, the second one. That gets us a little simpler before we start. Whoops, that's weird. Let's take that out of there. Oh man, sorry guys. All right, that's a mess now. All right, so those y's will cancel, and so now I can have this. I can multiply straight across. I'm multiplying x times x. This is like distributing, and then x times the y. If you need to, you can write it another step and go x times x plus y, because that's really what's happening there. And maybe that's best to show that here today. And then we have just y squared minus x in the bottom. Now, technically, you could leave it like that. Nothing cancels here, by the way. Don't think, oh, well, I have this x there. That can cancel with the x on top. And then I get this y squared. The y can cancel with the y. No, everything now is in a quantity, and they're being added. You can't do that unless you factor them out. So there's nothing that factors out of that denominator. This is really one of the simplified forms. You could multiply it through. This would also be acceptable. That is the simplest form of that fraction. Just leave it right there. Good to go. Guys, it's going to take practice, practice, practice with these things. A lot of stuff going on here with rational expressions. Enjoy, have fun. Don't make this laborious. Smile while you're doing your math. There will be some heartache with this, so just know that. All right, guys, that's all of lesson, what is this, 9-2. Get your homework done. Keep working hard. We'll see you guys later.